Hey everyone, and welcome back to the deep dive. You ready to geek it out a little?
Always.
Well, today we're diving into some research that could seriously shake up how we connect to the internet.
Ooh, I like where this is going.
Ever heard of cell-free massive MIMO?
I have, yeah. It's pretty fascinating stuff.
Yeah, and we're going to break it down for everyone listening, so don't worry if it sounds a bit like something out of Star Trek.
Yeah, it can be a bit intimidating at first.
Basically, picture this. Instead of having just a few big cell towers, we have a ton of tiny ones, like blanketing a whole area.
Like a mesh network, but on a much grander scale.
Right. Imagine being at like a packed concert, everyone's streaming, uploading, you know the drill, and your connection is still rock solid.
That's the dream.
The dream indeed. But there's a catch. All those mini towers, they're called APs, by the way, need to be connected somehow.
Oh, yeah. How do you manage all of that?
And usually that means fiber optic cables. But those cables, they're expensive and they use a ton of energy. Not exactly, good for the planet or our wallets.
Yeah. Definitely not. Not very sustainable.
But luckily, there's some really cool research looking at how to make cell-free massive MIMO way more energy efficient. And that's what we're diving into today.
Absolutely.
So let's start with the basics. How do they even begin to tackle this energy problem?
Well, one of the biggest breakthroughs is ditching those power-hungry cables and going wireless.
Going completely wireless. That's ambitious.
It is, but they're using something called wireless front haul to make it work. Think of it like supercharged Wi-Fi on steroids.
Okay, I'm intrigued. How does that even work?
Well, it leverages these high-frequency millimeter waves, or millimeter waves for short, to connect all those APs to a central unit. So instead of physical cables, they're using these super-fast wireless signals.
Okay, wait, hold on. I have so many questions.
Fire away.
So wouldn't all those wireless signals just completely interfere with each other? I mean, wouldn't it be chaos?
It would be a mess if they didn't have a plan. But that's where it gets really clever. They've combined two techniques, TDMA and SDMA. Think of it like, an orchestra.
Okay, I'm listening.
TDMA is like giving each musician their solo time so you can hear their instrument clearly. And then SDMA is like spacing them out on stage so their sounds don't clash.
I'm starting to get the picture. So each AP gets its own dedicated time slot and its own little space in the airwaves, so to speak.
You got it. It's all about organization and efficiency. They've basically created a super organized highway system for those wireless signals. Each AP has its own lane and its own time slot.
Wow, that is clever. So no traffic jams on the data highway. But we are just getting started.
Oh, there's a lot more to uncover.
I can't wait. Okay, so this wireless front haul thing, it sounds pretty wild. But aren't wireless connections a bit, flimsy?
That's a fair point. I mean, we're talking about transmitting huge amounts of data through the air.
Exactly. What if there's interference? Bad weather, a sudden downpour.
It's a valid concern, but the researchers have thought about that too.
Okay, good, because I was a little worried.
First of all, they're using those high-frequency M waves we talked about.
Right, the supercharged Wi-Fi.
Exactly. Those waves can handle a lot of data, way more than your typical Wi-Fi, and they're less likely to be affected by things like walls or other devices.
So less interference.
Much less. Plus, they've also designed these incredibly focused antennas. Think of them like laser beams for data.
The laser beams, wow.
They target the signals precisely where they need to go, which keeps the connection strong and stable even if there's some rough weather.
So it's like a super fast, dedicated highway for data, less traffic, and fewer potholes.
That's a great analogy. Now, another cool thing is how all these APs work together.
Oh, yeah, that's another thing I was wondering about. How do they decide which APs should team up to, provide the best coverage?
Well, they've actually got a really smart algorithm that figures out the optimal way to group these APs.
An algorithm, so it's not just random.
Not at all. It considers things like the signal strength, the channel conditions, even the physical location of each AP.
So it's like a strategic game of chess, figuring out where to put each piece to create the most powerful network.
Exactly. They're creating these little clusters of APs that work together seamlessly.
Teamwork makes the dream work, right?
Right. They call it chordal distance, which sounds complicated, but it's actually a pretty simple idea.
Okay, break it down for me.
Think of it like being at a noisy party.
Okay, I can picture that.
It's hard to hear someone standing right next to you, right?
Yeah, way too loud.
But if they move a little further away, their voice becomes clearer.
Oh, I get it. So the algorithm makes sure the APs are spaced out just right so their signals don't interfere.
Exactly. And that not only makes the network more efficient, but it also makes it more reliable.
Fewer chances for things to go wrong.
Right. They've minimized the potential for hiccups from the get-go.
It's amazing how they've thought of everything, from the antennas to the algorithms. It's like a well-oiled machine working behind the scenes to, make our online lives better.
That's a great way to put it. And remember, it's all about creating a system that's both high-performing and sustainable.
Right, so we can all enjoy being connected without, hurting the planet. But let's get down to what really matters. How does all this actually make our experience better? Like, what does the everyday user get out of this?
Well, first of all, say goodbye to buffering and lag.
Yes, please. I hate that.
With this technology, you're looking at faster and more reliable connections, even in crowded places.
So no more spinning wheel of doom when I'm trying to watch a video.
Exactly. Imagine streaming your favorite show in HD without a single glitch, even if you're in a packed stadium.
Now that's what I'm talking about. Faster speeds are always a win, but is there anything else?
There is. This tech could actually level the playing field when it comes to internet access.
Oh, tell me more about that.
Well, cell-free massive MIMO is all about spreading those APs out more evenly, which ensures that everyone gets a fair share of the bandwidth.
So no more fighting for a decent signal.
Right. It means better connectivity in underserved communities and those areas where network congestion is a huge problem.
Okay, I'm seeing the bigger picture now. No more battling for bandwidth at the coffee shop.
Exactly. And here's the best part. Because the system is so energy efficient, it could actually lead to lower costs for everyone.
Wait, cheaper internet.
Potentially, yes. If the network operators are using less energy, they can offer more affordable data plans.
Okay, so faster, more reliable connections, a fairer system, and potentially cheaper internet. This is starting to sound too good to be true.
It really is the kind of innovation that could change how we connect with the world. And beyond these immediate benefits, it has huge implications for the future of wireless technology.
The future, huh? What do you mean?
Well, as more and more devices come online, think smart homes, self-driving cars, all that, we're going to need networks that can handle the demand sustainably.
Makes sense.
This kind of innovation is a major step in that direction.
Wow, this is pretty mind-blowing. I can't wait to see how this technology develops and what it means for, the future of the internet. With energy efficiency this good, what other barriers could we break down to make cell-free massive MIMO more widespread?
That's a great question. It's a good one to think about. Maybe it's about finding more creative ways to manage how complex these networks are.
Right, because they are pretty complex.
They are, yeah. Or
Right.
maybe it's about coming up with new business models, ones that make it easier for companies to, adopt this technology on a bigger scale.
Yeah, that makes sense.
Hmm.
It really is amazing how fast technology is evolving. It seems like just yesterday we were all using dial-up, and now we're talking about, super smart antennas and energy-efficient networks.
It is incredible how far we've come. And this research really shows how innovation can not only, push the limits of what's possible, but also help us tackle some of the biggest challenges we're facing.
Absolutely. And it's funny, we started this dupe dive talking about how cell-free massive MIMO sounds like something straight out of a sci-fi movie. Right.
But it seems like the future is, it's getting here faster than we thought.
I agree. And that's what makes this feel so exciting. It's not just about, theories anymore. It's about real solutions that could actually change how we live and work and connect with each other.
So what's next? What are the big questions that researchers are still working on when it comes to, this technology?
Oh, that's a great question. There's still so much to explore, which is, I think that's what makes research so amazing.
Yeah, there's always more to discover.
Always. One thing they're really focusing on is scalability. Right now, they're testing these systems in, smaller, more controlled environments.
Okay, so what's the next step?
Figuring out how to scale them up seamlessly to cover bigger areas.
Like entire cities.
Exactly. And without running into any problems, it's kind of like, imagine going from baking a cake in your kitchen to running a huge bakery.
Yeah, the principles are the same, but it's a whole other ballgame when you scale up. Exactly. And another thing they're researching is security. As these networks get more complex and everything's more connected, making sure the data is protected, that becomes even more crucial.
So it's not just about making things faster and more efficient, but making sure that those connections are safe and secure too.
Exactly. And of course, the quest for better energy efficiency, it never ends.
Right. We can always improve.
Even though this research has achieved amazing results, scientists and engineers, they always want to find ways to, save even more energy.
Yeah, every little bit counts.
It does. Maybe it's about creating new materials for the antennas or coming up with even smarter power management algorithms. The possibilities are endless.
It sounds like the future of wireless connectivity is, well, it's going to be a wild ride.
It really is. There's a lot to look forward to.
It's been fantastic exploring this topic with you. Thanks
Mm.
for sharing your expertise and for making all this complex stuff so easy to understand.
It's been my pleasure. I always love geeking out about the latest tech, especially when it has the potential to make the world a better place.
And to everyone listening, thank you for joining us on this deep dive into the world of cell-free, massive MIMO, and energy-efficient networks. It's incredible how fascinating wireless connectivity can be. Until next time, keep exploring, keep learning, and keep geeking out.